Good evening, boys and girls, and welcome back to another flipped classroom video for a Granby High School AP Psychology. This is our final video in the research methods unit, and we're going to take a look at a subject that is everyone's favorite, and that is statistics, and specifically some really basic statistics that get into psychological studies. If you're an AP Stat student, this is going to be simplistic and probably something that's not even worth your review. But nevertheless, these are some basic statistical concepts that the College Board requires you to know and that you need to be able to understand how they can affect how you present the results in the study. So we start off with a really basic way of presenting statistical information. I guess I need to back up real quick and talk about what we mean by descriptive statistics. It's exactly what it sounds like. It is when you're presenting data in a way that you're attempting to describe what's going on. And so we're going to take a look at some basic ways that we have, or basic concepts in descriptive statistics here. One is what we call a frequency distribution. It's really just a table or a graph that can tells you the frequency of various outcomes in a sample. Okay, and so these two graphs are showing you the number of votes for your favorite food, pizza, hot dogs, or hamburgers. They're both actually showing you the identical set of data. And so these two graphs were chosen to demonstrate how simply how you graph data can be misleading sometimes. You'll notice that it's out of, or the maximum on the graph is 1,000. And when you look at the graph on the bar graph on the right, they all look very similar. They're all in the upper 950s, upwards towards 1,000. When you look at the bar on the graph on the left, it's made to accentuate those differences. And so it looks like there's barely anyone likes hamburgers compared to how many people like hot dogs. But in reality, it's just a 30 vote difference. And so the bar graph on the right might be a little more reflective of reality. So you have to be careful when looking at frequency distributions and bar graphs that are used to represent them to make sure you understand how the scale on each axis was determined and if that's really representative of what's going on. Now, another concept in descriptive statistics is something we call measure of central tendency. Measures of central tendency are trying to provide a single score that represents all of the data. You are very familiar with at least one measure of central tendency because you've been in school for quite a while. And that is, of course, the mean, or what we often refer to as your average. And that's essentially how grades have been calculated probably throughout most of your school career. And that average gets us one single score that then gets put on a report card that says, hey, this is how you've done in AP psychology class, for example. We'll take a look at some examples in class about whether that's the best choice to use in all circumstances in representing grades. But the three most common measures of central tendency are mean, median, and mode. I'm sure this is probably a review of elementary school math more than anything else. So I'm not going to get into, we're going to fly through how you calculate these. Of course, mean is the average. You add up all the scores, divide by the number of scores that you have, and that gives you your average score. Median is, of course, if you line up everything from smallest to largest, it's the one that is in the middle. And then mode, of course, is the most frequently occurring data point. So what we have here in this graphic is the income per family in, say, a small town. And what it is demonstrating is some of the limitations of using the mean when there are what we call extreme outliers. And what I mean by that is if you look at this graphic, most residents fall between $30,000 and $100,000 in their income each year. But there's a few outliers that make much more than that. And those few outliers push the mean income out to $140,000 a year. And then you have to ask yourself, is that really the best representation of how most people are doing economically in this town? And of course, the answers are no. The outliers have skewed it. And in fact, I think most times in economic data, researchers do use this the median as a more reflective or better reflection of how incomes are distributed, especially in a country like the United States, where there's some gap between the wealthiest and the least wealthy citizens. So when we look at median in this graphic, that seems a little bit better of a reflection of exactly how people are doing. About 60,000 seems like it's a little bit better in terms of representing where people are economically. In this case, mode would be a little bit low because while there's a lot of people that are on that one particular item, it seems a little low to represent the majority of that population. And so you need to understand kind of the strengths and limitations of each and when you would want to use them. Again, median might be better than a mean when there's outliers. When there's not outliers and the data is nice and tightly compacted, then the mean might be the best option. And mode is a type of central tendency where it might be important to know what's the most frequent thing that you're tallying. And so when you have those types of data sets, mode might be the best option. We'll do some real quick practice with this in class and then go on, because I assume most of you are pretty familiar with those concepts. One that is a little bit more complex, it's not really that complex, but is a little bit more complex is standard deviation as a measure of variation. If measures of central tendency were trying to come up with a single data point to represent an entire set of data, variation tells us the extent to which the scores within a data set are similar or different from each other. And so one way of doing this is, or a very simple way of doing this, is looking at range. So if we go back real quick to the previous data set, our range would be you take the high score of 1420 and subtract 30 from it, and you get 1390. That would be our range. That's a very crude representation of variation. It doesn't tell us a whole lot. And so researchers oftentimes try to get a little bit more complex with it and get a more nuanced view of the variation. And a way of doing that is by calculating a standard deviation. In this video, we're not going to get into how to calculate standard deviation. It's something that we'll discuss more in class, and we'll practice with a little bit in class. But nevertheless, just understand that the goal of standard deviation is to see the extent to which data varies around a mean. And you're attempting to be able to represent the data by using what we call a normal curve, or what's sometimes referred to as a bell curve. And you see one on the screen here. With a normal or bell curve, that middle point is always the mean score. And then once you've calculated a standard deviation, you can then know how many, what percentage of the population then falls within one standard deviation, two standard deviations, and how large those deviations are. The larger the standard deviation, the more variable your data is, and therefore the less reliable it might be. The smaller the deviation, the tighter your data is, and probably the more reliable it is. So just to give you a quick example without calculating the standard deviation, if we're taking a look at a particular type of note-taking technique, and we wanted to see how it impacted student test scores, well, if when we get the results back, student test scores are all over the place, ranging from 15 to 100, and lots of different scores all over the place within that range. That's going to result in a large standard deviation, and it's going to mean that the results don't necessarily they're not very reliable. They might not be consistent when we run the experiment again, and that may indicate that the note-taking technique wasn't a huge factor in affecting data. On the other hand, if the mean was at 88 and all on a scale of 100 on a test after taking notes in a specific way, and most of the scores fall in a real tight range, maybe from 82 to 98, real tight around that 88 number, then that might indicate a little bit more reliable data. So that's essentially what standard deviation is calculating. How tight is the data around the mean, or how much does it vary from the mean? And again, we'll get into more of that in class. So that's another descriptive, just describing the data and describing how it varies from that central point. So we talked about this concept of reliability, something we're going to get into much more later in this class. But essentially, reliability is the consistency of your results. If we were to replicate your experiment over and over and over again, will we get reliable results? Will we get consistent results? And the more reliable your data is, the more you're able to then generalize the results to a larger population. So you're more likely to be able to generalize from a sample if the sample is representative. We've talked about that in a previous presentation. If the sample is truly representative of the larger population. As we just discussed, if the sample has a low variability, then that's better for reliability purposes. And then the larger the sample, the more likely, or the less likely it is, I guess just to say, that the results are really coming just by chance. And so therefore, the more reliable the data would be as well. So just some factors that can get into data reliability there. Now, we've talked about so far descriptive statistics. Inferential statistics is something that you need to be able to understand what it is, but you won't necessarily need to be able to understand how to calculate various inferential statistical tests that you might do in an AP stats class. But essentially, the purpose of inferential statistical tests is to determine the extent to which researchers can assume that the differences between an experimental group and a control group were actually caused by the independent variable versus just being caused by chance. Okay, so what we want to know is, okay, we have this difference between a control group and an experimental group. So for example, going back to my note-taking strategy, let's imagine that we had one group take notes in a specific way and another group just took notes however they normally did it. The taking notes group ended up with a 92 average on the test, and the non-taking notes groups ended up with an 82 average. So we say, yay, we have a difference, and it seems like the note-taking strategy worked. But what these inferential statistical tests are going to tell us is, what is the extent that those results could have just happened by chance? Maybe the ones who took notes however they normally did it just had a bad day. Maybe the sampling wasn't quite right. So anyway, these tests get into that. And the general principle, the general goal that most researchers are looking for is they want the likelihood that the results occurred because of chance to be less than 5%. So we're looking for a p-value of 0.05 or less. That tells us that, again, the likelihood that the results happen by chance is less than 5%. Again, the general principle is you're looking for sample averages that are reliable, and differences between sample averages are large. That's typically going to indicate that the results are probably not caused by chance. Okay, so that's the second type of statistics, inferential statistics. You need to really, commit to memory this idea of p-values and what they represent, the extent to which the results were caused or potentially caused by just random chance. All right, so that wraps up statistics and psychology. Again, it's just a real brief overview. Again, we'll practice with this a little bit in class and take a look at some experiments that have been done and what the data tells us. Again, if you have any questions, you can email me at ghsteacher.com. Otherwise, have a wonderful night.